standardization in data communications. First we will look at protocols in general, what protocols are, and then we will look at something called the OSI Reference Model. And a protocol in telecommunications is a system of digital rules. So it's a set of rules which makes us able to communicate between devices. So, for example, if I have a computer here, sender computer, and I want to send it to a receiver, and on the way here I have equipment. So I need rules for example, how the connectors and plugs, how they are supposed to be formed, and what the different conductors should carry and so on. I need, for example, how the message that was sent from this sender comes to this receiver and not another receiver on the same network. So that is what is called addressing. I need rules on how the addresses are built and how they are understood. Earlier in an earlier film we talked about packets and how a large message can be split into packets and sewn back together into one message. And we need rules on how packets should be numbered and so on. So there are many rules in order to get communication from a sender to a receiver, and the sender and the receiver, or actually the devices and the software and hardware from the sender to the receiver, they must agree on those rules. And of course there are institutions and organizations that create these rules for us. The OSI model, the OSI is the name that is an abbreviation for Open Systems Interconnection, and it's a reference model. And it was created by ISO, so it's the other way around, the International Standardization Organization. What the OSI model does, it's a reference model, so it doesn't hold any protocols itself. It just says something about what a protocol should consider, or what it should define rules about, and what a protocol should not define rules about. Of course, if we have this communication system that we had earlier, a sender and a receiver, and there is another receiver on the same network here, and there are some devices along the way. Now, the manufacturer of the cable here between A and B, he doesn't care if the message sent on the cable is a mail, or if it's a web page search, or if it's a Snapchat or whatever it is. So he needs to, the manufacturer here needs to follow certain protocols that the software guys that create the web pages and so on, that they don't need to care about. On the other hand, those that create the software don't care about if the cable is copper or fiber. So therefore the OSI model defines what the different protocols should care about and what they should not. The ISO have divided internet or data communications into 7 different layers, and they are called the application layer, presentation layer, session, transport, network, data link, and physical. And how to remember that? You can say that all people seem to need data processing, and take the first letters, and then you remember the 7 layers of the OSI model. So let's study what the 7 different layers are about. Layer 1 is called the physical layer. It's the one at the bottom here, it's the physical layer. The physical layer is the physical link between devices of a network. So there we have everything that is required to get a bit from A to B, or a set of bits. So for example, voltages, bit rates, plugs and connectors, and so on. So what I should really say is that the layer 1 of the OSI model defines that protocols within this layer should consider things like this. So within layer 1 you have many different protocols. For example, the RJ45 plug, which is the most common internet cable plug, is defined somewhere within layer 1. So protocols within layer 1 should consider things like voltages, bit rates, and plugs, what you need to get a bit safely from A to B. Not if there is if it makes any sense. Simply to get the bits through. Layer 2 is called the data link layer, and that is where you define so-called local addressing. So now it start to make sense, because if I have a sender here and I have numerous different receivers in a network, well, it's important that a message goes from goes to the correct receiver, for example B2 in this case. So layer 2 talk about how can we make sure that the receiver is the correct receiver. However, it doesn't consider how the most efficient way to reach from A to B. It simply makes sure that the receiver and the sender agree that the message should be between the two. On a larger scale, number 3, the network layer, then we talk about the most efficient way between the two. So for example, if we have this is as you see Norway, you have Bergen here, you have Tvedestrand here, and there are many different routes from Bergen to Tvedestrand, even by car, but of course for a data packet as well. So there may be routes like this, all possible ways to go from B to T, and the network layer makes sure that we find the most efficient way. What is most efficient one day is maybe not the most efficient the other day, because there may be things happening along the line. Just like when I drive the car, sometimes there is snow on the mountains, which means that I should follow a route through the coast, or maybe I have to go inland because there is traffic jam for some reason here. So that's by car, but the same thing is by when we send data packages. So the network layer, or protocols within the network layer, make sure that we create the network in the most efficient way. The transport layer is how packets are split, or messages are split into packages, sent individually, and when they are received at the receiving side, how they are put together in the correct order, and if a packet is missing, that packet was lost along the way, well, you need to request a new packet to be resent and receive it. So the protocols within the transport layer make sure that all the packets are received and sorted in the correct order at the receiving side, and packets that are missing, that they are requested to be resent. Layer 5 is a session layer, and that is to establish a connection, hold the connection throughout in the communication, and close the connection afterwards. So protocols within that layer make sure that such establishing connection, maintaining connection, and closing connection, that takes place in the correct way. The presentation layer is about coding and decoding, for example. How can you say that the JPEG image should be coded in another way than, for example, a BMP image, and things like that. The application layer is the final layer, and that is, for example, what does the alpha in an email mean, and what does the, for example, the HTML code. You write some code within brackets. HTML is the web page code. What do these codes mean? What does the alpha in a mail address mean? And so on.